over to Jodie.
Thank you. Giving people... Thank you. The giving people power and voice, I think, is probably the most important part of the introduction, and the bit that I don't claim to hardly remember and have much leverage into is the formal methods bit. But I hugely respect people who did formal methods, and that's probably about as far as it goes. I'm very happy to be here. So first of all, let me thank you all for inviting me, including Matt, who's sitting at the back, and Simon and Jen and Alan, who've been very busy on organising an interesting schedule. I'm really very happy to be here. I'm not going to give a kind of bio of myself, except to say that you can get a bit of an idea of the kind of the pieces of me. That's the more formal bit of me, and this is what I'm mostly going to be talking to you about, the citizen science part, which I really enjoy talking about and doing. And one of the things I want to try and do is to persuade those of you who are maybe not involved in citizen science, but who are part of the Computational Foundry and have access, or will have access, to very powerful computing resources, to think about how you might apply those in a citizen science context, both locally here in Swansea, maybe across Wales, maybe across the whole of the UK, and maybe internationally as well. So that's the kind of thing I'm interested in. So let me start by just seeing who's in the audience. How many people maybe think of themselves as citizen science? I'll define it in a minute, but does anybody recognize that label and think of themselves? Ah, Matt, wow, thank you. How many people think of themselves as maybe being bird watchers? A couple of you, great. How many people think of themselves as being environmental advocates? Quite a lot of you. Okay, great. And how many of you are, do we have any undergraduate or just graduating students here? Great, congratulations. Master students? PhDs? Wonderful. Faculty and staff. Great, okay. Nice mixed audience. Thank you very much for come to this talk. So, very broadly, what I'm going to do, the plan for the talk is I'm going to define citizen science very generally. I'm going to talk about a few major research issues that come from within the sort of citizen science work that's going on, illustrating these largely through different projects. I'm going to take you on a little survey of a few projects. And then I'm going to talk about some of the issues that I think are really interesting research agenda issues, and particularly issues that might have broader impact. And that's where I'm hoping that some of you who are doing things like sentiment analysis, machine learning, all of these different, really topical areas and powerful areas of computing might sort of say, I could apply what I'm doing in those areas to the citizen science area, and maybe also within the computational foundry kind of idea. So let me start with a very simple definition of citizen science. It's basically a partnership between scientists and volunteers to collect and analyze data. I'm actually going to open that up because a lot of what this original definition, which comes from Rick Bonney in the US in 2009, and Jonathan Silverton, who some of you may know, who was at the Open University for many years, who's now at the University of Edinburgh, and are both really foundational researchers. Both of them are biologists, and most of what I'm going to talk about is from the biology point of view. And one of the things I'm going to be talking about is how the definition of citizen science, which tends to really emphasize the collecting of data, needs to be broader and broader if we're going to really energize and motivate citizens to get involved in citizen science. But also, it does have the word science in there. So if you're doing science, there are also issues about data and data quality that are really important. There are thousands of citizen science projects that are being done across the world. The ones I'm going to talk about are basically concerned with biodiversity, because that's my passion. But if you know of Zooniverse, you'll know that there are a lot of people who are looking at galaxies. There are people who are looking at involving citizens in all kinds of different ways, categorizing music, translating old documents, looking at wrecks of ships. It's all a type of crowdsourcing involving citizens in the field in these different kinds of projects. And of course, citizen science, I give you those definitions that come from 2009, but that's a little bit of a joke in some ways, because if you think back, citizen science has existed for an awfully long time. Darwin could be described as a citizen scientist. He collected a lot of data. He developed evolution through the origin of species, but he was very lucky. He had a lot of money, but he was a citizen. He wasn't a paid professional scientist. People like Mary Anning, who collected fossils in Lyme Regis, and many, many others. So the concept of citizen science has been around for a long, long time, particularly from the mid-19th century in the Victorian era. So why is it sort of becoming interesting, and why are people like me and some of you getting really interested in that? Well, of course, it's really a lot to do with technology, huge amount to do with different kinds of technology. We've all got it in my hand, but cell phones, smartphones, which are very, very powerful, and one of the projects that I'm going to talk about is primarily smartphone-based and touch screen-based, but there are also an increasing variety of sophisticated types of technology. Drones with cameras. This is a colleague at the University of Maryland who works in Kenya and has drones going across areas of Kenya looking for poachers and looking for activity there. And of course people like the World Wildlife Fund and many of the conservation organizations are very into using drones. Some very tiny ones, some the size of little insects like dragonflies, and some much larger clunky ones like this. So the technology is really the basis of why I think citizen science in the last few years, bringing together technology and biologists, is actually really taking off, because we can do things that we couldn't so easily do before. And I'm not going to run through all the different types of technologies, but of course satellite imagery is also a big one. All kinds of things, sonar, sound, a variety of things that you'll see in the projects that I'm going to talk about. So I've been involved in citizen science since, well, I've been an enthusiast, a nature enthusiast for many years, but about 2009, 2010, the National Science Foundation in the OU, in the United States, I've got OU on my brain, in the United States, put out a call for crowdsourcing projects, and a couple of us across the United States got funding for projects in that area. And since then, a very large number have developed. So what I'm going to do is just show you this little video, which is about our project. Our project, this is a recent project. It's a 2.4 million project funded by the National Science Foundation that involves 3 universities, headed at the University of Maryland, but also University of North Carolina at Charlotte, and the University of Colorado at Boulder. And basically what this project is about, and the way it's developed, is about crowdsourcing data collection. And in the 2 centers, one in Charlotte and one in Maryland, we're working with 2 different groups. Our group particularly works with a group called the Anacostia Watershed Society. And you'll get a little introduction to this, but broadly, the Anacostia River is a river that runs through the eastern part of the state of Maryland and also the District of Columbia. It's an important historical river. It's an area where ships used to regularly come in and collect tobacco and things like this to take over to Europe, and also bring things from Europe across. But it became very silted up. It became very polluted, extraordinarily polluted. And when now that the population is growing, in a way this is getting better because it's becoming somewhat gentrified, but it's also creating problems in that the system that supports it is a sewage system that was developed many years ago to support a much smaller population. So one of the things that happens is when we get very heavy rainfall, it washes all the stuff off the streets, all the stuff off the lawns. People put weed killer on their lawns, they put fertilizer on their lawns and stuff. The whole lot goes into the river and into the watershed, and is carried out into the watershed, into the Chesapeake Bay, which is one of the largest estuaries in the world, and where it's a big crabbing area, and then out into the ocean. The Anacostia Watershed Society has been doing a terrific job on trying to educate and involve the public, and they've really been extraordinarily successful. And so we have been partnering with them to try and see how the technology that we can develop actually supports the community. And the technology that we're using is, by the standards of the kinds of things I've mentioned, pretty modest. We're using primarily smartphones and also touch screen displays. But as I will talk later, actually for many people, for all of us, that's like a very modest, ubiquitous technology for people in this room. But for many of the people that we're working with, it certainly is not, for a variety of reasons, either economic or they're not able to afford the phones, or they don't feel comfortable using them, or our system isn't as usable as it should be. All these kinds of things create barriers. So let me play you the video, and this will describe the overall project that we're working on. I have to find it on here. Whoops. Wrong way. You'll get it from me. Okay. Had a complete meltdown with my machine earlier, using vents. Here we go. It's called
We often miss the beauty and importance of nature that surrounds us. This project is centered around understanding what happens when we start paying closer attention to plants and animals, waterways, parks, and backyards. Researchers at the University of Maryland, the University of North Carolina, Charlotte, and the University of Colorado are working with community partners at 2 local nature centers, the Anacostia Watershed Society and the Reedy Creek Nature Center, to develop technology to support a deeper understanding of and more engagement with local environments.
The tool we are developing is called NatureNet. It helps communities carry out projects in their own local environments.
In Maryland and the District of Columbia, volunteer watershed stewards learn about improving the health of the Anacostia River by creating projects to manage stormwater runoff. NatureNet helps them map, capture, and share information about their projects with each other and the public. At Reedy Creek Nature Center in Charlotte, North Carolina, naturalists develop projects that will help park visitors to use their mobile phones to collect data to understand more about nature in the park. Visitors can come in from the trails to see their observations and those from other visitors on a large interactive screen at the kiosk. We are now studying the impact of NatureNet on people's knowledge of local environmental issues and actions, their understanding of science in their everyday lives, their sense of connection with nature, and their scientific, computational, and technology skills. Are you interested in joining forces with others in your community to better understand and protect local places? Then NatureNet may be the tool you need. What is NatureNet? NatureNet is designed to evolve in response to users who recommend new projects and technology improvements through the Design Ideas feature. We think this is a first, crowdsourcing to guide the evolution of a location-based citizen science platform. And now, we're encouraging its adoption and adaptation in many other outdoor settings, from parks to environmental stewardship programs to your own backyard. Here's how you can get started. Participants in NatureNet can also influence the design of technology that they use by offering design ideas, which they can input via the app or website. Interested in learning more about the impact of NatureNet? You can read more on our website, download the apps, or check out our research website, research.nature-net.org, where you can track the use of our system through real-time visualizations. And follow our project on social media. We hope that NatureNet will expand and support data collection and communication around environmental issues that matter to you and your neighborhood. Help make a difference in your local environment. Contribute your nature observations to NatureNet today.
Okay, so that is our project. I'm going to talk about this in just a minute. One of the things that we're interested in, when we first envisaged this project, we thought of it as being a large network of local groups. We've really struggled quite a lot. We're working very closely with local groups. And when I talk about local groups, actually what happens at the Anacostia Watershed is that people come in, they do about 8 weeks of a class program there. So they learn about what the watershed is and how to manage and help manage a watershed. What are the problems of pollution? How to do some things that you can do anywhere in your backyard. For example, one of the problems, as I mentioned, when it rains, you get very fast runoff. So if we can persuade people that instead of having a concrete driveway, they put down something that's porous, bricks, with gaps between them, or gravel, then it slows the water running into the watershed and causing those pollution problems that I mentioned to you. Also, can people collect runoff, the rainwater in rain barrels? How do they get rain barrels? How do they link those rain barrels up? All these kinds of things. So some quite simple, basic community kinds of things. So we've been working with what they call the Watershed Stewards, who are local people. They come from various ethnic different backgrounds, Caucasian Americans, African Americans, increasing number of Hispanic Americans, new immigrants that come into the area, because the Anacostia Watershed area of housing tends to be a lower cost area that people come into. Though one of the problems is that it is becoming gentrified, so that is having an impact on people's ability to be there. But the stewards come in, they do these 8 weeks of classes, and then they need to do a capstone project. And that's where they leverage what they've learned on their 8 weeks to actually do a project with the local community. So they then become the leaders, and they get a group of people around them. And that group can vary from like 2, 3, or 4 people right up to about 20. So what we're trying to do is to support those local groups with the kinds of technology that you see there. I thought, naively, that this would be fairly easy to do. It's extraordinarily hard, actually, to get people really involved. And even though we spent a lot of time in my research group understanding why people do citizen science, what they like about citizen science, what they don't like, their use of technology, it's very difficult to get local people involved. It's also quite difficult to get scientists to really engage with local people. And some of the projects that the stewards are doing have a direct impact on science. Some of them are looking at, for example, how wild rice grows, what the local fauna is like, how invasive species are moving through the area. Others are doing things like trash collection, which has a direct impact on the stream and also has an advocacy group. And believe it or not, they classify the kinds of trash they collect and they weigh it, and then that information goes to policymakers in Maryland and DC, and it results in more money for more local activities. So it's both an advocacy activity and it's also a scientific activity. But let me just turn with that sort of background now to just talk very briefly about some of the things that are really big issues in this kind of project like we have, and in many citizen science projects. It's 2 basic groups, of course, when we talk about citizen science, and I emphasize the word science. There are the biologists in this case, people who are very highly trained, most of them, or they're extremely well-informed amateurs who have often skills that are almost as good as professionals. I'm thinking of bird watchers in this case, and many others. But for many scientists, they've done a first degree, they've done a second degree. Jobs in biology are quite hard to get, so they've maybe done even 2 postdocs, and then they've got a job. So if you come from that kind of background, you have a basic problem with how can citizens collect reliable data for me? So that's one very big issue. The trustworthiness of data. Another issue, of course, is if you're working in a research area, is we all, I don't know exactly what the situation is in Britain now, but certainly in America, often funding for science research is getting cut back. So from the scientist's point of view, there's both a plus and a negative. There's a concern about the quality of the data, and there's a plus that, well, gosh, I haven't got many resources. If I could get 50, 60 or more people actually helping to collect data for me, that would be extremely helpful. And one project, which I won't get into talking about this time, but there is a project called COAST that exists on the West Coast that's been going on for about 18 years, where researchers from the University of Washington have been collecting data on beached birds. And that data is being used to trace death with changes in weather, climate, also changes in migration, etc. So there are many projects that are getting involved in citizen science. But from the scientist's point of view also, as well as can I get enough data? Is the data trustworthy? I also want long-term citizen participation, because if I spend quite a bit of time training people to collect that data so that it's trustworthy, I don't want them to just come in, stay for a few days and disappear again, or stay for one session. So getting people to come back is also a big issue. So those are major issues that I'll talk about more in just a minute, but from the citizen's point of view, and this is an area that my group has done quite a lot of work on, is, what motivates citizens to get involved? We know that initially, a lot of it is about learning and contributing to science, wanting to learn more about your passion, of what birds are here, what animals are in your environment, what's going on in the environment around you. And then with increasing, I think, concern about changes in the environment, climate change, if you believe in climate change, and pollution, population, more and more habitat for wildlife is disappearing in many places. So animal populations and plant populations are being severely squeezed. So many citizens are coming in from the advocacy point of view of wanting to learn and also wanting to contribute. But we also know that as people become involved, they want to be acknowledged for their work. And this is one of the things that's a little tricky, because often scientists may not always remember to acknowledge the citizens, or the citizens don't know what the acknowledgement is. Probably not reasonable to expect them to be co-authors, although some of them could be, but certainly an acknowledgement of some kind on, for example, published papers, talks, etc. So those are sort of issues between these two groups, and that's also why I mentioned at the beginning that that initial definition of citizen science is a little bit limiting. And this is just a little quote that comes from a recent EU project. I don't know this person. It's Dr. Golombek. Maybe some of you know her from the EU. She's recently published, 2017, in a pretty new journal, Citizen Science Theory and Practice, a paper that's entitled Between Vision and Reality. And what she did, the EU was very, very interested in having some of their projects get involved in citizen science. So in many respects, a prerequisite of getting your project funded, probably on some other area of technology or smart cities or a number of other really important things, but to get that project funded, there was a strong push to get involved in citizen science. So Dr. Golombek and her colleagues interviewed a number of people who were on these projects, a number of the scientists in the biology area. And many of them were really not very convinced about the value of citizen science. And this quote sort of summarizes the concern, the concern that some people have, and that a few people have the ability to contribute. The vast majority simply act as potential locations for sense of deployment. I mean, when I read that, I go, because people are not sensors. I know we think of crowdsourcing in a kind of way of people being all of us out there collecting data, doing different things. We're sort of like the sensor. And of course, biologists for many years have deployed sensors in terms of temperature probes and in terms of, collecting rainwater or monitoring air and all of those kinds of things. But you can see here, to me, this kind of summarizes some of the problems that we're sort of dealing with between maybe the view of what many scientists are still feeling a major concern and what citizens from the previous slide are really wanting. In other words, the engagement issue between the two different groups. So the next couple of slides are from projects that are really tackling that. I mean, our project is tackling that in a number of different ways. But I wanted to mention a couple of projects that you've probably heard of. Iceblock Nature, which was actually developed by Jonathan Silverton and his colleagues from the British Open University. And it was first developed in 2009. How many people know Iceblock Nature? I know Alan does. A couple of you do. Yeah, I think it's an absolutely terrific project, and I'm just going to talk about it a bit generally because I want to bring out in that discussion some of the things that I think make it successful. First of all, as with our project, it's embedded within a broader educational system, so I think that works very well. It's embedded with the OU, the OU's classes use it, and also their MOOCs also use it. So with that comes support for people who get involved in using Iceblock Nature. When I collected these figures just before Christmas, there were about 57,000 plus users. Some of these people are biologists and trained scientists. Some of them are regular people like myself, who's a pretty poor bird watcher, and others, and general participants. So with Iceblock Nature, this pointer isn't strong enough, and I'm going to point out a few things. It does have a nice welcoming interface, but the point that I want to make, that I want to bring out most, is some of the ways that we tackle this problem of participation, getting people to participate, and at the same time making sure that the scientists are getting reliable data. And what I like very much about this system is the fact that you can collect data about a whole range of different organisms, and these squiggly little things represent them here. So you can see toadstools, you can see, I think that's insects, butterflies, birds, etc. They don't use the full biological taxonomic classification because it's big and broad, but they just use a few. And what is pretty amazing, and I think conceptually, about what the designers of this system did, they allow people to collect in these different areas. And then, in order to make sure that the data is quality data, they invite others to comment on, for example, the classification. So if I put this ant in, or I put this flower in, I might have an idea what the name is. I might try to classify it, or I might not. Or I might just send a message out asking others to classify it. Or I might just put it up and other people may come and classify it. Even if I don't classify it, other people will be looking in. And here's how this works. As well as being the category into which you can put data in, it's also the category into which you can contribute and you can build up your reputation, which I think is really neat. And they have this reputation system that's built on a number of different criteria. Others may be doing it now, but when they first did it, I think it was probably the most sophisticated around. So I could, or anybody could collect data, and the reputation is built up on a variety of different things. How much data have I collected already? and how well have I classified it? How accurately have I classified it? That's one part of this. The other parts of the reputation are, so that gives me some, stars as a reputation. The other part of the reputation involves, do I have professional training? Maybe I am professionally trained as a botanist, so I would get a 5-star reputation as a botanist. But maybe I don't know much about birds. I'm a pretty poor bird watcher, so I get a 1-star reputation as a bird watcher. So that's another part to it. And then there's yet more to it than that. How much have I actually helped other people to accurately classify their own systems? And that, I think, is really exciting and really key, because that is a motivation for bringing people in, getting people to work together and to help each other. So you can have different reputation for different parts of the system, which is really nice. You don't have just one blanket one, you have different ones. And what I thought was really interesting is that it's a number of years ago now, it's at least 3 or 4 years ago, they did a little experiment which is reported in Zuki's. You can find this online, actually, on their site, with Jonathan as the first author in 2015. And they took a sample of plants, 2,234. They must have cleaned the data and lost a few along the way. And 1,053 moths. They were classified on ISPOT by this ISPOT system that I mentioned to you. And they were also sent across to the UK Biological Records Centre. And the agreement between the classification at ISPOT and the classification at the UK Biological Records Centre was 94% agreement for plants and 92% agreement for the moths, which I don't know how many biologists there are in the audience, but to me that seemed like pretty good, actually. It really seemed pretty good. And ISPOT, crowdsourcing and bringing people in to help get the data to be good data, and also to give people a sense of involvement, seems to work pretty well. So another system that some of you may know, oops, I keep going the wrong way because Ben's pointer's the different one to mine, is eBird. And some of you will probably know eBird. It's phenomenally well known, and if you're interested in technology and things like machine learning and some of the other state-of-the-art computer science that's going on, you can probably be sure that the people at Cornell who are involved in eBird are using it. They have huge, really huge data collections. They've been collecting data on birds and bird sightings, bird migrations for many, many years. The lab was formed in 2002. They have so many sightings that it was really hard to get the data on the number of users, but it was certainly 200,000 plus users. It now goes right across the world. In December, they've got about 370 million bird sightings of over 10,000 species. It's pretty incredible. And that one works in a similar way. So quite recently, I was in Vancouver, and I'm a very amateur bird watcher, and I spotted a bird which was black and very streamlined, and I thought, that's called a Crackle. And it was quite a long way away. And I kind of made a bit of a guess, because I couldn't see it very well. I thought it was a common Crackle. I entered it in, and within a couple of days, I got an email from one of their local people. They divide up the areas, and they have local experts in that area who got in touch with me and said, yes, we know that bird. We've seen it really quite a lot. But actually, it's not a common Crackle. It's a boat-tailed Crackle. And sent me a really nice note. Will you please correct your sighting and put it up for eBird? So again, that's a nice way of bringing education and also making sure that the data is collected. And they have a phenomenally sophisticated way of local people all around who go out and check sightings. So, for example, one of you might be a birder here and very well known and an expert in your local Swansea area, But if you go up to Glasgow, you would have to prove yourself again in Glasgow in order to be recommended. So again, this is a way of, you know, bringing together the issue of data quality with the issue of community and involving the community, educating the community, making the community feel like they're contributing. And they have all kinds of tools for identification of birds. The educational scaffolding for, you know, amateur birders is really very, very good indeed. And then this is another one. Anybody use iNaturalist? This one is developed in America, and this is one of the reasons I asked about master's students and undergraduate students, because originally this was developed in about 2009, about the same time as Iceblock Nature. But it was developed, the very initial concept came from a project with 3 master's students in the information school at the University of Berkeley. And since then, it has grown to be huge. It's now based in Caltech, and it's funded by NSF, it's funded by a lot of different people, but it has continued basically through the sheer drive of a few people, one who is a biologist but with some pretty good technical chops, although not a computer scientist, and a computer scientist called Kenichi, forgotten his other name, but who is very savvy on the computing side. It's a super model for, you know, something that a group like the Computational Foundry could get involved in. About 20, they have on busy days about 20,000 observations a day. They're across the whole world. I mean, one of the reasons I like it is I can do it at home in Bethesda. I'm quite often in Canada. I can do it there. I can do it here. I can collect data anywhere I like. They had a BioBlitz, which is when you bring a lot of people together and they collect on a particular topic, maybe the insects or invasive species or whatever, in a particular area. And that's also a very motivating thing, because I really strongly believe that face-to-face married with online is very motivating for many people. So their BioBlitz, they collected 124,000 pieces of data. They're aiming for 50 million observations by 2020. Their aim is to record data on species across the world. The argument being, of course, that we're losing species, we're losing numbers, and we're also, some species are going extinct. But how can we actually know what's happening, what's going extinct, if we don't know what's there in the first place? So that's part of their aim. I've got a lot more observations to my name than when I made that slide, but I'll tell you a little story about last summer. This was last summer. I was in Windsor. No, I didn't get invited to the royal wedding, not this time. And I was visiting an ex-student of mine and was wandering along the bank. I'm a pretty lousy bird watcher, as I mentioned to you, so I'm also a very bad photographer. So I took that picture, and I kind of made a rash initial guess. I thought, the only bird I know in Britain that has pink legs is a grey-lag goose, but those legs are a bit, really, very pink. Anyway, I didn't have time, so I put in grey-lag goose, and within minutes, I put it in then, 14 minutes later, John 8, whoever John 8 is, jumped in and had taken off my grey-lag goose and had replaced it with Egyptian goose and had tracked down the biological name in the index and given its biological name for that. Now, I was talking to Alan earlier, and Alan was saying that he thought people might get a little bit, ooh, I did that wrong and you corrected me. I personally didn't feel that. I could see that some people might, so that's something you need to take into account. So anyway, I wrote to him and I said, thanks, John, very pleased to see it. I knew I'd seen one before, but couldn't remember what it is. Bright pink legs are amazing. So that was my little experience, and it's another way of involving the community in making sure that the data is good, but also making sure that people feel engaged in the community. So what I should have mentioned before also with the, well, I mentioned the UK biological records. I mean, things like Iceblock Nature feed into that much larger database. This also feeds, when you've got enough people, you know, it moves from being, mine was casual grades, it went to needs ID, well, it got its ID from John 8, and then it moves up to being research grade. It's a kind of lower level, not as sophisticated way of doing it as the Iceblock Nature, and not as robust from a scientific point of view. But nevertheless, it can then go into larger databases like the Encyclopedia of Life and GBIF and those sorts of things, which then also check it through. So anyway, they also do leaderboards. This is interesting. So people get onto leaderboards. I've only got 3 here, but if you check this online on a laptop, not on the cell phone version, there's something like 6 different leaderboards. There's crazy numbers. So people get ranked for their observations. This was, as I say, around about Christmas, I first made this slide. Almost 14,000 observations. I find that phenomenal. Often the people who are at the top of this are pretty professional. They've got sophisticated cameras and stuff. So most observations, most species, most identifications. So what is kind of nice is that, you know, it's not just most observations, it's not just most species, but it's most identifications, which includes helping others as well. And you'll see that people like Sam Biology has helped a lot in identifications and also is pretty high on those species. So when some of my groups saw that, they went, oh yeah, leaderboards, that'll solve our problem, we'll put on about leaderboards. But it's interesting, you always have to take context into account. When I did some reading on leaderboards, I discovered some interesting things. Leaderboards tend to, people who are confident like leaderboards, people who are successful at most things like leaderboards. There's a bit of a gender difference. People who are male tend to like leaderboards often more than people who are not male. And also many minority groups, and our projects group was particularly trying to encourage minorities. Minority groups, according to some research, are not eager to get involved in leaderboards. And I should also mention that one of the other problems with minority groups, particularly in the US, is that sometimes those groups, African Americans, they associate going into nature historically with going into danger. That was where, you know, some of the persecution of the African Americans would happen. So they don't, and still they don't often like to go to national parks. Their attendance at national parks is very low. Anyway, so that's another technique for involving people. iNaturalist does some other things. Of course, it takes advantage of social media, so it puts up, you know, the observations for the day, so people get feedback and rewards from doing that. They have and they do Blitzes, and they're actually very good about acknowledging other people's contributions. So that gives you just a little bit of background of how I think we deal with these 2 major problems of scientists' need for data quality and involving people, and participants need to kind of be involved and get feedback. So this was just my list, and I would be very interested in hearing what you think of, you know, possible agendas and broader impacts. A lot of these are already happening, but certainly much at the top of the list comes if you're doing pure, citizen science for science. I mean, sometimes it's for advocacy, but if you're actually collecting scientific data, then ways of convincing scientists is really important. And I think that's where the Computational Foundry has a really amazing, sort of starting point, because, you know, you're the ones that know about big data, you're the ones that know about InfoVis, you're the ones that know about machine learning. You can bring these kinds of techniques, working with community members, biologists, subject specialists, into making, technology really powerful and to help people in citizen science. Increasing participation, I think that is a huge one. Increasing diversity. If you look at pictures, one of my talks, I don't have that picture this time, but if you look at often who are the citizen science, you see there are many people who are my age. There are not often, and often kids, groups in schools, there are not so many people the age of many of you younger people in the audience. So, you know, making participation in citizen science sexy and interesting across the full diversity of age range, gender identity, racial, ethnic diversity, I think is really important. Bringing technology tools, design thinking is a big topic at the moment, but this is also where it comes into what I said at the beginning, if you remember that the definition of citizen science is rather limited. There is much, much more involvement, both in terms of thinking of the tools and also the next one down, involving citizens, is to involve them in all stages of projects. And the project that I'm interested in, that I showed the video of, we particularly want people to decide not just on collecting the data that, you know, Dr. Professor, bigwig person has decided that they want, but what do you need for your community? You know, what does your community want? Are you worried about a local stream where, you know, your older kids used to go and catch fish, but you can't let the younger ones go because it's pretty nasty and people have got thrown broken bottles and stuff into it. What do you want? What do you want to do with your local bit of the environment? So these community-driven environmental projects, which means that you involve people in identifying the problem as well as working on finding the solutions all the way through. Maybe using some of the techniques that I've described, although those are successful in those very big projects. How do we scale them down for small projects? That's what I'm trying to think a bit about at the moment. What other kinds of technologies might we bring in? Sound, touch, extensions to existing tools like, you know, special lenses on microscopes, cameras on smartphones, all of these different kinds of things that, you know, at the Computational Foundry you could make, or you can work with engineers and you can try them out in projects with your local communities. Of course, I mentioned just involving citizens in all stages, not just as data probes, but getting them really engaged in what it means for them to clean a stream or monitor their air or stop runoff from local areas. And then some oldies, but very goodies. Maintain, scale, archive, reuse, share data, and experience. And these, I think, are reuse, share data, and experience. Again, one of the things Alan brought up when we were chatting is, wouldn't it be great? You say there are thousands of citizen science projects across the country and the world. How can we get those projects to work more together? And that is starting to happen. Many people are feeding into things like Iceblock Nature and iNaturalist and eBook. But could we create small local projects that really motivate local people? And then maybe they'll network with other local groups in the Swansea area. And maybe they'll network across Wales. And maybe you'll become known as the centre for this network of small community-driven environmental projects. And people will learn from each other in doing those things. And that maybe is a good place to stop. I had a couple of extra slides that if you're getting into this topic for the first time, I'm not very modestly suggesting 2 general articles of my own. One is in Interactions, the Interactions magazine, and the other one is in a journal. But if you like popular books, there's a couple that I just really think are wonderful. By the way, David Attenborough is doing, I think it's butterflies and moth spotting activity across the whole of the UK. The David Attenborough equivalent in the US is a guy called Edward O. Wilson, who's an emeritus professor from Harvard. And I'm like somebody going to a rock concert, you know, I'm adoring my Edward O. Wilson. And he's written a very interesting book which is called Half Earth. It came out a couple of years ago, and he is advocating for we need to give half of the space of the Earth to wildlife and wild animals. Now, of course, politicians, and probably some of you think that's really unrealistic, but read his book, and that will challenge you. And then another one that I think is just wonderful is called Walden Warming. Richard Primack is a botanist at the University of Massachusetts. Walden is Emerson's local pond from Victorian age. And he used to go out and collect data on flowering times of all the plants and things that he saw around the pond. And what Richard Primack has done is taken his students out to record local flowering times, which are several days and in some cases weeks earlier than they used to be in Victorian times in the mid-1850s. And of course, the suggestion is changes in climate. So there's those kinds of things as well. This is a very interesting read. And then finally, that's the group in the US, but you have a European group, the European Citizen Science Association, which is quite small, run mostly out of Germany, but it's quite active. I have not met with them a lot, but one of my students works with them a lot. And then if you want to look at different kinds of citizen science projects from across the world, there are several hundreds, maybe over 1,000 now, on a system called SciStarter.com. So that was all I wanted to say, and thank you for having me here. And I'd love to talk. Just thanking my gang and the NSF for giving us money. Thank you, NSF.
We'd like to start questioning. Do you want, actually, yeah, I was going to also suggest, do you want to flip back to your challenges slide?
Oh, sure.
But we've got, I've not forgotten, it's a good thing, but you just thought that might be a good point just to have City up there whilst. Yeah. But anyway, so, I know your name, was it Ruth?
Ruth.
Hi, Ruth.
I've got a question about the absence of data, because as you know, in biodiversity studies, particularly if we want to know changes over time, it is as important to know that a species is there as you know it is not there anymore. Now, when you do your research, then you make sure that the absence of the species is indeed an absence of the species. If you have a citizen science project, if a species is not recorded, can you be sure that it wasn't present, or was there nobody there?
Yeah, I think that's a really good question. I think there's really there are only a couple of ways I think of dealing with that, and it's really hard. If you know something should get recorded, I think you probably have to bring in experts who know the area really well. And they might be professional biologists, or they might be just really professional, really local people. Like, I was astounded when this guy popped up and said, oh yeah, we've seen that bird. We know about that bird. And it's not that, it's that. And of course the birding community is phenomenally onto that kind of thing. So bringing in your experts, I don't know him, I don't think he is a professional ornithologist. I think he's a very informed person who's taken on the role of kind of monitoring what happens in that particular area and knows really a lot about that area. The other thing is that, the benefit of crowdsourcing to collect the data is that you hope that with crowd and an increase in the crowd and a very mixed crowd, that you won't miss, and if you miss once, you might not miss the next time. But one of the things that people worry a lot about, they don't have the slide this time, but all of us, not all of us, but many people focus on what people call charismatic species. And a lot of what makes an ecosystem work are the things under your feet that you can hardly see, the centipedes and all the nematodes and all these things. And often there are not experts covering that. So getting a complete log of everything that's there is probably pretty close to impossible. But, you know, hopefully for certain important areas, you've got experts focused on particular projects. And you're not just collecting in a general way that, for example, I showed you from ISPOT Nature, and I'm a naturalist, but you're actually focusing on birds, or you're focusing on a particular group. And so you're attracting people with those interests, and you're attracting some experts as well. I know that's really what the Open University does with Iceblock Nature. You know, some of their MOOC projects and their early foundation level and even their third level courses on ecology use that system, and it's focused. So they're looking at particular species or group of species. Yeah. Don't know if that answers a really good question. Yeah.
I wanted to ask a question about your hard-to-reach groups.
Yeah.
So I don't work on citizen science, but I work on outreach a lot.
It's hard. Yeah.
And we kind of get in this loop with hard-to-reach groups and low participation groups, that they are just by definition low participation. So I wanted to find out whether your work has sort of built you towards some groups of things that we need to do that we actually can. What would get less represented communities involved in our naturalists, so that things that happen differently?
It's really, really hard. We're particularly focused on African Americans and Hispanic Americans, and we definitely have found that obviously having those people working in our projects really helps, and that's the sort of general philosophy within, I think, education. I was dean for a number of years, and by increasing the number of people in a group at different levels, that when you look at them, you go, oh yeah, you look like me, that is extremely helpful. So we worked really hard within our own research team, and also it tends to work within the community-driven projects. They tend to collect together their own groups. But if we want to get projects that are interesting to African Americans or interesting to Hispanic Americans, the chances are it will work a lot better if we have representation from those groups, particularly the person leading it. So that does tend to happen. The projects also vary quite a lot. As I mentioned, it's just known within the US, although I must admit I didn't know it to start off with, is that many of the African American groups, because of the horrible history of slavery and lynching and things, still they don't go to national parks as much as Caucasian Americans do, for example. So, finding, I think, projects that are comfortable for them in their local area. So rather than encouraging people to come over here and do this, what interests you and your kids in your area? Those are sort of really foundational things. On a very sort of basic difference, we do all kinds of things. Food is really good to get groups to kind of come together and feel like they're a group. And then, for example, if we haven't really done Blitzes, those I've been involved in those, but there's other people running them. But having snacks and things so that you get people talking and socializing. And being careful not to jump to conclusions. I mean, I mentioned the thing about the leaderboards, which, let's say, some of my group had, leaderboards. And then when we read more about it, it just, I don't think would work on the small-scale projects that we're working on. It works on these big projects. I haven't yet, actually, it would be a lovely student project to analyze the diversity on some of these leaderboards. And I have a very strong indication that I could predict how it would come out. But those are the only things that I can predict. Topic, others looking like you. Really cool, actually. They're just the very human things. I think one of the things is, pulling from what we all know in sort of a community basis as human beings and thinking about it in terms of how it works with projects that use technology. I mean, we tend to, if we're not careful, over-focus on technology.
I think the examples you gave, you mentioned the beginning, lots of biological ones. And when I think of citizen science projects, UK Spring Watch is the one that jumps to mind.
Yes.
Typically that, I think that might be about accessibility of nature. It's an easier one. But then as we were talking, I was thinking about on Facebook, you've occasionally seen these maps of where people use the word used for the shoes that you wear in the gym, are they DAPs or plimsolls? What do you call the meal at 12 o'clock in the day? And these sort of map. So it's interesting how it's this sort of range of things, especially so that, I don't know, obviously some sort of computing people here, there's also general sciences, College of Sciences people around. I don't know whether there are non-biological, non-computing universities here, but I was just wondering about some of the other range of citizen science projects you've seen.
There's a huge range. I probably should have mentioned it a bit more, partly because it is from the UK, and it's also extremely successful. It's Galaxy Zoo and Zooniverse. And Galaxy Zoo grew out of a project in Cambridge in which a PhD student had huge amounts of data about galaxies in the sky and could not really do his PhD in terms of analysing these data and identifying, possibly new galaxies on his own. It would have taken him years to do it. He came up with the idea of crowdsourcing. That was one of the very early ones. I think they started about 2009 as well. And out of that has grown the Zooniverse platform, which I should have mentioned. I love Zooniverse. The only reason I tend not to mention it is that citizen science is very broad. And I like the kind of citizen science where you go out and do things as well as you use the technology. And Zooniverse, they do some of these sorts of things, but it's basically an online platform. So, for example, a young friend of ours who is 12 is very passionately interested in animals. And Zooniverse has camera traps across places like Serengeti, and they just stream pictures of all the animals and stuff that are going by. And so you can go into Zooniverse and you look for Serengeti, and 12-year-olds, younger and older, people can go in and classify the animals. And there's good scaffolding, has it got pointed horns? Has it got curly horns? Has it got stripes? Is it all one colour? And they help you to try and sort this out. And a lot of young people find this really challenging because, maybe you only see the tail and the back end of an antelope, or maybe you only, it's occluded, you've got something else standing in front of it. But you get support in actually identifying what's being streamed. So that's an online version. And then there's the people doing astronomy. There is a project that's about shipwrecks, which I think is also on Zooniverse. There are loads of different projects, and that actually would be a very interesting platform for some of you to look at, because they now have software there which is open to the public to use. And so, it's one of the things we were talking about is we shouldn't all be replicating and building these systems when other people have, as we've discovered, had more money and done a better job. Even though our project is supposedly quite big, it is limited. So Zooniverse has a platform there. You can take their software, they have templates, and you can build up some of your own projects. And then they review those, and they've got about the first 100 of some, I don't know what their review mechanism is, but they're kind of featured on the Zooniverse site. But there's many, many more than that. And so, just as people did in the early days of websites, they would put up, templates. I've forgotten the name of the really popular system for developing your own easy to develop websites. Can you remember, Ben? Anyway, similar sort of idea for developing a citizen science site. Also, if you go into iNaturalist, they have done a lot of work now on providing templates for small local groups. And if Computational Foundry gets into any of this stuff, it would be terrific to have, maybe some of your students analyze the stuff on what's offered on Zooniverse and what's offered on iNaturalist for small local groups, because you could see, what the power of what they're offering is, which is very easy, I think, for local people to use. And then how you might supplement it with you know, some of the heavier computational techniques that you guys could bring in. Have I answered your question?
Yeah, that's fine. Oh, yes, we've got a few, 2 more, yeah. So I don't know, you had it first, so I can come back to you on this one, yeah.
Yes, okay. So there is similar successful projects in the you don't know if you heard about it. It's called array coordinated.
Yeah.
So it's basically the same idea, and I think people get more into that because they, like, you know, the ladybirds, they are colorful, you can get this offer from it, and it is a successful one, and there is much of papers published based on that. It's also used by a nice lady, like she's called, like.
Yeah, thank you. Yeah, I haven't explored that a lot, but I do know about it. That also has the advantage of being very focused on one group of organisms that are pretty diverse and can, you know, it's pretty easy to evolve.
As you said, diverse is fair, so they can, like, identify the species, and they know already about their variation from the species and their distribution in the UK.
Yeah.
So there's lots of data on that. Yeah.
Thank you. Yes, and I encourage you also to look at the David Attenborough. You know, I've forgotten what it's called. Somebody knows? I know that a cousin of mine who is not involved in my projects at all, but we just chatted a bit, told me that, I mean, she's been, you know, that she's tracking marbled white butterflies up in Yorkshire. You know, that is another thing, and I think also having David Attenborough behind it is probably very helpful. But that might be something, you know, some of you might want to think into. I haven't looked at how the data is collected and how it's uploaded and cleaned and stored. I mean, there's a whole issue, of course, cleaning this data as well as checking it and stuff like that.
I was wondering, could this approach as well be applied to producing software? Because I know there are lots of hobby programmers on this world, and they have much more time than we have. Many very enthusiastic, so involving them in some production of some software.
I'm going to hand this question over to Alan pretty quickly, because the open software groups have been doing this for quite a while, right?
Yeah, in one way, but I guess the interesting is as you said, if I instantly think, well, of course, there's loads of open software projects, but actually there is a slight difference between the ones which are more about producing things and software as science, and I think that's probably more where you're at, where the sort of things that are cutting edge, and yet perhaps there are things that can be, as opposed to, should we say, more production software. So it's interesting. It both sounds like, well, of course that's already done, but actually then thinking again, I think perhaps there are gaps there.
And one of the things that I didn't really emphasize in our project, but which we're working on a lot at the moment, is that I think you've probably all heard of participatory design, which has been big in HCI for many years, and there's various forms of it. But basically what it sort of boils down to is various ways of working with the user, the people who are going to use the software. And a lot of that is done face-to-face, and that's traditionally how it's grown up. Our project has done that face-to-face participatory design, but if you remember in the video, people are invited to give design ideas. And the idea of that is that there's 2 parts to it. First of all, if the usability is not nice and they've discovered some usability problem, they can say, hey, you know, this was pretty horrible, I expected it to do this and it did that, and etc. But it also gives people the opportunity to suggest new things that they might want for their community-driven project. Now, we've had a few problems with this, and we've had to, the lady at the back has gone now, but she asked me how you get people involved. I mean, we've had to put some of our comments up in order to have some comments there so that other people felt that they could be comfortable putting suggestions up. Because one of the big problems is that people feel like, if I make this comment, oh, maybe I'm really stupid. You know, maybe that's so obvious. So you have to help people pass that kind of situation. And we haven't really done a huge amount on this yet. The technology is there, and you can look at, it's nature-net.org. We had to put the dash in because somebody else grabbed that nice name before we got there. But if you look at nature-net.org, you can see how that works. And The problem that happens then is that you get suggestions and you don't have enough programmers to react quickly enough to implement some of the ideas. Well, first of all, you need to work out which ideas are probably going to be good ones to use. And our way of doing that is to have our software team evaluate them, and also to have the whole project team evaluate them, and also to try and get the community to evaluate them. Like, it's useful for your project, could somebody else use it on their projects? Because if we do it for you, it'd be much better if like 3 projects are going to use it. But it's been very hard to get that to work. But I think there's a basis in doing that. And of course, if you can, it gives you a real way of enabling people to tailor software for their own projects and therefore to have buy-in. Computational Foundry could provide that energy to do that, maybe. I mean, a group of, hot undergraduate programmers could have a go at some of these kinds of things.
That's a good idea.
In a group project, yeah.
I'll sort of start to wrap up, and but there's more fruit at the back. I was also going to say we've just sometime in April next year this morning Claire, who's Claire? Are you still here, Claire? No, gone. But Claire, myself and Ben and Jenny. We were discussing we'll be having a festival of ideas in April time, or April-May time. And part of that's going to be around some of the topics that Ben talked about on Tuesday, and part of it's about citizen science and issues. And I think particularly probably, I mean, not for the former, but I think for the latter, the spread of people here, there may be both community groups who might be interested in these kinds of things, but also academics in the university yourselves, or you might know people. So if you would be, if you're interested in events around those things, give me a shout, and I'll keep you informed and in the loop. And we'll probably be sort of looking for ideas and particularly contacts out into the community for that. Okay, so thank you very, very much, Jenny, and
Thank you, everybody.
hope you enjoy the rest of your visit here as well. I think you've been a good time. We've been meeting more people enjoying the day.
Thank you. Thank you.
Trying to stand back up for this.